okay, that's what I want, 800 bucks. Bam. So that's what I'm trying to do, as many and as often as I can at a time. Now it varies a little bit depending upon environmental conditions. If it was in a lake or a river, there's some expensive stuff that you have to buy to clean the drives. And so those things are kind of added to the cost. But typically my labor side, I'm making 800 bucks. And we're going to do everything we can not to change the hard drive from a data standpoint, where the user's data exists. There's two pieces of data that you really have to think about. The hard drive is a functional computer. It has its own operating system on the drive. So it's firmware, and it's firmware based, and there's tables, but as we know it, it looks like a computer. It has a way to write to itself, make changes, look at where content is, it boots, it has a command prompt, everything that you would normally think of as a computer. So I can change the data that is that portion that helps me get to where the user stores data. So elsewhere on the drive, maybe in a different location, in higher density, something else, there's a set of data that belongs to the user, and those are located by what's called LBA blocks, logical block addressing. So logical block addressing is a term that we got from SCSI, and we've relayed that and pieced that over into IDE and SATA hard drives and a continual list of all the other hard drives. Logical block addressing means that every block is in order, from 0 to the end of however big the drive is. And every block is so many bytes big. And for default, at the moment, we're going to say 512 bytes. So every block, all the way back to 1982, when we're talking about the first hard drive in that picture, is 512 bytes going forward. Now, we've got some newer things that are slightly different. I'll get into those on Wednesday. I don't want to confuse any of this issue, because the majority of those things, even though they're bigger, are logically broken back up into 512 byte blocks. So everything that we look at normally is 512 byte blocks, and I'll cover the newer stuff that's not later, but let's not confuse it now. So I'm trying to look at the user's data from 0 to however big it is. That's the part that matters to me. I can manipulate the rest of the drive and do whatever I need to get it running enough that I can see that user's data. Does that make sense? So that's what all the hardware is for, is to manipulate that data to get that far. There is also some that can be considered user data that is part of the operating system of the drive, which in forensics can cause you a different problem. In testifying, it's not really a real problem. It's a testifying problem, which is, did you make changes to the drive in order to actually get this data? And the answer would have to be yes, but I can't tell you how many times people have testified they said no when they made substantial changes to the drive. There is one piece that crosses the line that's user data that's part of both the operating system and technically user data, and it's called an HPA. It is a user changeable configurable item that the user can store data in, but typically is only used for geometry on the drive. Again, if I'm saying any words no one knows, that's fine. I teach by redundancy. We'll go through all of those things, and by the end of the day, you'll understand those things, okay? Because they are important things, but we will get to that spot where I discuss those. And then, basically, we're going to cover the basics of Mac, Linux, Windows, and then as much as I can on solid-state drives. I wish I could tell you that it was a beautiful world and it was getting better and it's easier, because so many people out there, I'm not kidding, every day, I have battles with these IT guys, and people are doing podcasts and things that are just like just praising solid state as if it is the best thing that's ever happened in the world, and basically not even telling people to back up their data. I'm like, this is horrible. This is a horrible thing to do. And once I describe how bad it is, they understand but they don't feel like they have the experience with the drives that displays that, because they think they're going to live forever. They think they're going to live for 50 years or a million years. I've heard a million years. And some of these don't even last 3 weeks. So it's horrible. It's a horrible world. And if I could tell you anything, here's the other part of this. I can recover of all drives given to me unless there's a horrible scratch on the platter. I can easily recover 95, 96% of almost everything given to me. If there's a platter and it's intact, I can probably figure it out as long as it hasn't been manhandled by somebody else who did some horrible thing to it first. Destroyed the board or killed the ROM, something like that. Solid state, that world is 30% or less is my, and I talk to everybody on the whole planet who is doing this. And there's a lot of marketing hoopla. There's a lot of stuff out there trying to explain how good things are and what kind of wonderful world it is. But I'm going to tell you now, it's even getting worse. I would have said a few years ago, in 2010, I would have told you this was a 50 to 80% chance you could recover it. But today, and they trash them so quick, like nothing that was used 2 years ago is still in use today. Like it's gone. Like they've gotten rid of it, it's over. So we'll talk about those things and we'll get through those. So I want, real quick before, so we're going to do a break at what would be 10:30, but I want to talk to each one of you and try to get your experience, what it is that you're looking for, where you're at. This is just a sample of questions. It's not meant to be the specific list of questions. And if you don't want to be recorded, don't say your last name, just say your first name or whatever, so you guys will all get chummy by the end of the week. So if you don't mind, would you start, sir?
Yeah, I'm Rob. I don't really work in the data recovery business per se, but I have some issues that with some large disk arrays that were like huge MD RAID configurations and drives that didn't wear level right, is what the vendor eventually said.
Okay. In solid state?
No.
Okay.
They were rotational ones. And the array had gone through different vendors, like major vendor changes, and so there was a lot of arguing what was going on. I'm interested in.
It's not HP, is it?
No.
Okay.
I'll tell you. I can tell you later.
Okay.
I have a deep spar that I have used and done a little bit of stuff for family myself. I've done head replacements, circuit board replacements, and I kind of want to see what's new with the software that you've got.
Right.
And what's changed in the hardware since I have not done much of the total or the PC 3000.
Okay. All right. Awesome. But it's mostly RAID arrays that you're trying to deal with from a standpoint of.
Yeah, like big arrays of,
like SANS and NetApp and stuff. Any of those?
Mine. Well, actually, I was doing Luster and GTFS.
Okay.
So I was usually able to put the bad drives back in and DD them.
Right.
And after a few days, it would go through and then be able to reassemble the MD RAID arrays. But I was losing drives faster than I could replace them.
Right. Okay.
As well as happening.
All right. So do you currently have a stack of ones that you're trying to recover from?
I don't. I actually, that problem RAID array was replaced. Once ago, so
okay.
I took great pride in sending it to be destroyed. So.
Okay. All right. Awesome. All right.
It was about 4 or 5 years of the more you used it, the more you had to replace drives.
Yep.
And
that's over. Do you know the branded drive that was in the array? Okay. All right. Well, I can
stop the other one.
All right. We'll stop the video, whatever else later. We'll talk. Okay.
My name is Katie. The answer to all the questions is no. Basically, I'm here. We originally had a hard drive recovery committee at our office, and everybody's kind of moved to greener pastures, and nobody's touched our backlog in probably a year. So
you do have a stack. You've got a stack.
Yeah, we've got a stack.
Right.
Most of ours are our drives that we purchased, sent on-sites, done imaging to them. When they come back to us through FedEx, they
click. Yep.
So that's what they're. So when we go in next Monday, they're expecting us to kind of hit the ground running.
Yep, and start running through. So you really are starting this job on Monday. Okay, all right. And so can you give me any insight into what the drives are, what brands, what?
Mostly we purchase Western Digitals and Seagates. I know after a few of our people have taken their course, we started purchasing the laptop drives.
Okay.
But as far as what's in our backlog now, no, we don't.
All right, okay. And what equipment is available to, because you guys both work in the same office, right?
Yeah. So we've got your heavy 3, we've got your 2000, your toilet and heat.
Okay, so you got everything that you need, right? Okay, all right. And anybody else working on that? Like who else who was the previous person?
Her name was Candace.
Okay,
Yeah, and she's moved to a different department.
okay. Do I know Candace? I met, yeah, right, she's been
She's
here.
gone through your class, yeah.
Yeah, okay, all right, yep. Okay, anything to add?
Name is Doug.
All right, okay, and so you guys haven't looked at a single one of the drives that are in the stack at all, or nothing? Like, so you guys transitioning from a different position to this position?
No,
Just all of a sudden, you just have to do more?
Duties as assigned. We've experienced a lot of turnover in our office.
Mhm.
So basically, if there's a lull, we're gonna steal from Pete, pay Paul, or however that.
Okay,
Yeah.
all right, okay, that's good, congratulations, you guys. All right,
Tim, I've tried a couple of those swap printed circuit boards to no avail.
Okay.
But have a video and film restoration company, and everything's on hard drives. And a lot of them are starting to click.
okay.
Fail now. So I need to come up with a solution.
What did you guys use before hard drives for storage?
Just hard drives,
Okay,
no LTO.
okay, so, and that started in 2005, you said earlier, is that right? So, all the drives that you have are basically a window of 2004, 2000-ish, somewhere in that range, to current?
Correct.
Okay, so you're still buying hard drives and adding them into the mix, and then constantly going through that process? Is there any redundancy or using anything?
Yeah, I'm backing them up.
Okay.
The later ones, because they're so big.
Okay,
The 8 or 10 terabytes, I mean, if you lose one, you...
right, yeah, you've lost a pile of work.
60 files.
Right, yeah.
And they're all video files.
And
First time.
So now basically, because of all these previous problems that you've had, you're now duplicating those drives as you're imaging to them,
Yes.
or putting the content on them?
Mhm.
Okay, all right. And so, and newer drives, have you still been having problems with the newer drives?
Not
Yet?
so much with the newer ones.
Yet,
I've been exercising them before I use them,
right?
and that's one of the tricks.
Okay,
that I found out.
okay,
Get the infant mortality, when you first fire them up, they either work or they don't.
right.
Sometimes.
So these 8 and 10 terabytes that you've been buying, are you buying helium drives?
No.
Okay, all right, that's good. Just making sure. So we'll get around to those things. All right, so the older drives we'll be able to address very easily. The newer drives, as we're starting to get into those 8 and 10 terabytes, you'll find out that they're less stable. They're going to be more problematic over the long haul. And I guess my primary advice would be to start actually considering whether or not you want to use smaller ones and have more of them, or redundancy in other ways that may be more reliable. Because, so keep in mind that the people who are buying these 8 and 10 terabyte drives right now mostly have been the commercial RAID array businesses, and they've got multiple drives in the array, and when they die and they fall out, they've still got something that they can rebuild or live with from that standpoint. But we're seeing them in droves and recovery, and they're much harder because most of them are called shingle technology. Yeah, and so basically they're multiple layers of stack, just like the shingles on a house, and they become much more sensitive for head assemblies to do recoveries from as well. So I would be considering an additional way of doing these from that standpoint, and but we'll talk about that. We'll go further with that, and then we'll deal with all the clicking in the old and the other ones that you have that are problematic from that standpoint. And most of the time when they're clicking, they've just been sitting somewhere for a long time, and then you plug them in and they click.
Right.
Okay, so temperature changes and things like that could be an effect of part of this? Like, are you in an area where they're in a safe or they're in a colder environment?
It's room temperature.
Okay.
73, 72.
Okay, all right. And you maintain that consistently? Okay, because on older Western digitals, as an example, there's a screw that shifts. And the screw, when it shifts, causes the head to click. So if you were just using them as opposed to the ones that are live in a real lab environment where they're running and the head might have died and scratched the platter, these have a pretty good chance of survival because they weren't plugged in, they weren't running. You picked one up and then you plugged it in and now it's clicking, and there's a good chance that a screw in the head assembly shifted based on temperature change. So that would be Western Digital's mostly, would be that problem. Prior, other than that, there will be a whole nother set of problems for some of the other stuff, but Western Digital's, that's a traditional thing that's happened with forensics people, is that we've had Western Digital drives that have been sitting on a shelf or in a safe somewhere, and a temperature change happens, and then this screw shifts, and they're easy to recover from because all you gotta do is back the screw out and put the screw back in and start making adjustments to the screw, and then all of a sudden it'll come live and it'll start working again. So you have a pretty good situation with regards to those, whereas the Seagates will be something else because those all have screws in the head assembly. The Western Digital's are the only ones that don't have a right one inside holding it in a different place. So, but we'll go through all of those from that standpoint. But I might be a little more cautious on these newer 8. Like, I would feel more comfortable if you told me I bought 3 of them and I was cloning them to 3 different drives instead of just 2. I feel like you've got a similar problem that will happen with the 2 together. At least if there's a third, then you can migrate off of that before it happens. Or keep a live RAID 6 array alive with the data on it and keep other drives as the backups, if that makes sense. And then that way you know when something bad happens here that your last alternative is these others that are already running. But in a cheaper way, like there are cheaper ways to make this happen that'll be large enough for that to happen, but I'll try to go through some of those with you that make that easier from that standpoint. Okay. So how many terabyte in total do you think that this archive is?
I got about 1,600 drives.
Because I saw you make like drive cases and stuff too. Yeah. So you make like
because I got tired of tripping with them.
Yeah, you make and sell these drive racks for people, shelves. Right? Mm-hmm. Yeah, shelves. And so, and how many of those do you have full?
Probably 10. 10. Well, no, I've actually more than that. Because I've still got them in the styrofoam containers.
Okay.
Because even though I build the shelves, I don't have enough for myself.
Okay.
The time to build them.
All right. We'll make an estimate of the amount of data.
Yeah, there's about 1,500 drives or more. 3.5. So 3.5.
Well, that's good. Okay. All right. Sir?
Side note, do people send you helium-filled drives?
Do they send us what?
Helium-filled drives?
Yep.
What do you do with those?
Well, I would like to say those are easy as well, but they're not. Your hardest problem is the survival of the disks while you cut them open, because they don't have screws. They're not like a regular drive, and so I don't have a CNC machine that could cut through that. So basically, you have to saw them off, and it's a very, very difficult process because in the process of sawing them, there's no way to keep any of the material from falling inside the drive. So I've spent a bit of time trying to work that out. I don't have a good solution at this point, and the CNC people that I've seen, even their solution isn't great. Basically, they're using like a shop vac while they're chopping this thing open to try to suck the stuff back up so that it doesn't get inside the drive. And that's not a good solution either. I mean, my best solution is never to use a helium drive. Like, the theory behind a helium drive, while it sounds sound, isn't turning out to be that way in reality in the living lifespan of these drives. We'll get into what all these things are later, but they thought it would be good to pump helium into a drive and seal it because helium has a different density than air, and so therefore you can move your head closer to the platter and store it in a higher density. And that's where things go wrong, because that higher density is 10 times the density, and it is very, very difficult if you finally get to a spot where you can replace the head assembly on the helium drive to get it into a position where you can actually recover the data anyway. So they've further complicated it by sealing the drive, which they say is a lifetime seal, which, helium is one of those gases that escapes from anything. and it will eventually escape from these drives no matter what. There's not anything they can do no matter what they tell you to store this content. And surprisingly, helium is the other problem with helium is it's not anything to do with the drive. It has to do with the fact that it's actually becoming extremely rare. And helium is only produced in the United States, and so they have to export this to other countries. We actually have helium reserves in this country, a lot like we have gas reserves underground in storage. And it's a finite material. There's not any more of it. So it's not like they can recreate it or make anything else out of it. Originally, surprisingly, this is just, I know terrible trivia, things like that. Like the Hindenburg was supposed to be filled with helium instead of hydrogen, but we were in the beginning of just before the war, and we would not export it to Germany. So that was why they didn't use helium in the Hindenburg in the first place, or any of them. They were filled with an explosive gas instead of, but recently I've seen many new scientific reports on how low our reserves are actually getting and how expensive that helium's going to get. I'm surprised we're still using it for little balloons inside of Publix and things like that. I think eventually you will see the last days of helium. Like eventually it will not be distributed to any of those places, or it will become increasingly expensive to the point we're not going to use it anymore. And for them to be adding additional items that they need to do this in a scientific, even though it doesn't seem like a lot, it's a lot when you consider the number of drives that is needed for such a specific type of element. So it's getting worse. It's going to get worse from that standpoint. But eventually I won't have to worry too much about helium drives anymore for that very reason. As the cost goes up and they're starting to try to use it, they're going to stop using it in the drives, because anything that adds a penny to it, I'm not kidding you, a penny added to the cost of a hard drive, they just stop. They don't use, I don't care if they need a little piece of plastic in there and it costs a penny, they will not do it. So they'll do the minimum, the bare minimum they ever need to do inside of drives, and I'll show you that as we're going through drives. They'll do anything they can to cut costs and chop it out. So I think eventually we won't have to worry about them at all. But there's still a very small number of them out there in the field. So, and most of them are in RAID arrays. So.
My name's Patrick. I don't really do much with hard drives. I do chip-offs typically. So I like to learn about the hard drives just in case my coworker gets hit by a bus and then I have to start doing them. So most I've done, we have an Atola. We just got a task force. We have the Insight. The Insight's what I've played with the most. We have a PC2000 that I've played with a little bit, but I don't want to like blow the firmware away, so I haven't really played too much with it.
Right.
And then most of the stuff I've done with drives has just been imaging, so like a Falcon or a Ditto or.
Okay.
So I haven't really done much with like physical repair on the drives.
Okay. And so you're using the Insight mostly, so the USB one?
Yeah. Okay.
I mean, kind of obsolete at this point. Like when the forensics one came out, because the Insight, I have them all, and I have a task force. So I'm one of the rare people. Again, you're rare, in your department to even have a task force, because they're $21,000, and they're very hard to get, and there are a very limited number of them. It's a different version of an Atola for forensics, for mass collections, basically is what it is. Hey, have you guys seen this? You guys know? So it doesn't have all the recovery features of the Atola itself, because they sell it as if it's an Atola on steroids. That's my only real downside to it. I've had very large quantity of discussions about what it's doing. They will eventually migrate it to some of the other features that are the Atola forensics. But it does not currently have a bunch of the recovery features. It has mostly imaging features. So it doesn't have the controls and the things. But the forensics version is the one that's the most advanced of the storage and what it can deal with content. So I have 3 of them here in the class. I have the task force. I didn't bring the Insight with me. I haven't used it in years, because it is, the difference between the Insight is it's dependent upon the machine it's connected to, because it's basically being controlled directly 100% by that Windows machine over a USB connection. So it's very slow from a standpoint of transferring data, and it's not even USB 3, it's USB 2, right? So So it's very slow. Whereas the Insight, compared to the forensics units, the forensics unit and the task force are embedded Linux boxes where they have direct control, and you're sending the command to it, and then it's doing the job, basically. And they use a Surface Pro on the task force in order to control it. But, and it's basically got a web interface that you can control from another machine. But again, I'll set up the forensics ones, the two that I have here with me, and then I have one up front. So I have one connected that I'll switch to and I'll show. But so we'll go over all of those things. But I'm interested in doing your chip off. Do you feel that you're equal to, or my assessment of 30% is about right?
Depends on what I'm working on. I don't usually work on drives. I typically work on phones.
Okay, right. So you're
various things.
right. So in the phone world, are you doing mostly Androids, iPhones? What are you?
I don't usually touch iPhones. It's usually Android.
Right. So
the underfill's been the biggest issue for me so far.
Yep.
Which, depending on whether they need the phone back, I'll either cut the chip out or I'll use them for it. So it really kind of depends.
And how bad is encryption getting for you?
Oh, it's pretty rough. Some of the stuff I get is like they're years old, right? Where encryption's not so much of an issue.
Right. Prior to like even 3 years ago, it was great, right? But the last 3 years has been a nightmare.
Yeah. So it really depends on what I get done. I haven't had too much of an issue with encryption until the past couple of months. I've just been consistently getting things that are encrypted.
Right, because everybody's switched to new phones, new stuff.
Yeah.
They go through phases every 3 years where they get rid of the old stuff and new stuff and starts over again. And except for the iPhone world, our world has been terrible up until like last week. Like last week is the first time I saw a glimmer of light that I haven't seen in years. I mean, literally since the 4S came out, we've had nothing but a struggle at getting content. And by the time that we actually got anything that was updated enough that we could even get like a 4S, if we were getting anything from it, it was so many years later that it was unimportant at that point. It's kind of like Blackberries. You know, it's like, you know, there's this thrilling world of people who still do Blackberries. Which I haven't seen a BlackBerry now in, like, some countries get them. Australia, Canada, they're using them, but we haven't seen them live. I mean, how often have you seen a BlackBerry anymore?
I've only seen one.
See, but because there were so many tricks with BlackBerries for reading those with the chips, like you could actually go through the process. Are you guys doing phones? Yeah. So
I'm not personally, but our office does.
okay, right. Celebrate though, primarily, right? And you guys are using the DoD version, huh?
The tool that cannot be named, yeah.
Yeah, right. The tool. Well, I can name it. I don't have an NDA. So the $200,000 plus with the credits, basically, that you have to crack phones, which still cannot crack a 10 or 11. Is it 10? 11. I don't know if you can crack a 10 yet, still though, right? Can you crack a 10? So the 10s have a hardware problem, have a huge hardware problem, which is why they were completely discontinued like overnight. Like there's some sort of problem with the facial recognition component in it that when it dies, it causes the phone to go into a loop forever and ever and never comes out of it. So it's a physical hardware problem, and they decided rather than replace them telling anybody about it or do anything, we're just going to kill it and then just come out with the 11 and a completely different piece of hardware in the process. So I have a 10, and the day is going to come, and it's going to be over. But here's the thing: saying that and doing exactly what I'm doing is exactly what we're talking about in solid state. People don't know that there's these problems, and that day that bug or whatever kicks in the firmware, because solid state is all software. I mean, like, I know people think, oh, it's all hard. Like, the NAND chip is dumb. There's nothing to the NAND chip. It's literally a dumb piece of storage, and all the tricks that happen are all done with the controller and the interface and wear leveling and software and all these other things that are happening to it. And the guys who are writing software for that, I feel like it's the millennial generation. Like, I feel like that. I feel like all of a sudden there was these guys who were like, you guys with hard drives, you don't know crap. Get out of here. You guys are mechanics. let me show you how it's really done. And then they wrote a piece of software over here, and then later on, that thing, a bug kicks in, and it dies a violent death and takes your data with it. And it's incredibly difficult to get it off, especially with the new, everything's encrypted, and it's all in a monolithic chip or something where it's all in one chip, and you can't get it out, and the encryption's tied to the chip, all in one, right? Is that how you feel? Like, this is pretty much our life at this point. So your success rate, if you were going to rate this, you would say, well, like thumb drives are the easiest of the set, right?
As long as it's not like a monolith that I don't have to figure the pin out for.
Right, yeah, which, again, that's the other problem. Every 3 months, it feels like all the pinouts for all the chips change. They're all different, and you're trying to find, even for something stupid like a SD card, it's a nightmare to find the correct chip pinouts, because you basically are going to take a piece of sandpaper and you're going to sand it down till you get past the epoxy and you can see the pinouts. Then you're going to do micro soldering to all the pins, but you've got to know the pinouts and what they are. They're not labeled. There's no labels or anything there. And then label them, to the right places so that you can read it with the tool that you have. And then you've got to hope the chip's not cracked. Nothing else, like you don't know, and you don't know till you do it. Like you can sit there with a microscope and you can go over and over and over the chip and not see a crack, but then you do all this wiring and try to hook it up and then it just doesn't work at all. Like you get nothing out of it. And that's, again, if you know the XOR pattern or the encryption process by the time you get the chip, right? So you can see all the people laughing that have done this for real life. So here's my problem with this. It's not even all of that. My problem is, how much money do you spend to get to there? Because all the equipment, you're upwards of $20,000. So you spend, let's just say, just flat out that the number, an easy number might be, let's just say I spend $10,000. I buy, so Resolute is probably the highest of the infant tools that are, because basically we're still in the infancy of this process. There's nothing about this that is robust, repeatable, or easily affordable. So let's just say you spend $6,000 on that. You get all the stuff you need to for soldering. You get anything else that you need on the other end of that. There's also PC3000 Flash, which is has a whole nother set of problems altogether. Like it can't figure out exclusive OR processes, and so you have to. And this is. Once they've saved all of the processes. So once you have all the processes saved, then at that point in time you can then repeat those processes. Does that make sense? Like they have a script process that you can do, and if it's already been solved and they already have a solution for the chipset that you have, you can repeat that process. But I try to break solid state up into multiple categories. You have your thumb drives, which I call the easiest of the group. Like most of the time the thumb drive's problem is that somebody broke a connector. So data recovery is different than forensics from that standpoint. In data recovery, I just have to get the thing running again. I don't need to do all these tricks. If I can do it without doing chip off, then great. I only need something from it that is somewhat functional, and my client will help me. If there's a password or anything they need, we'll get that. Then you move from the thumb drives to SD cards and whatever you're using for cameras. That's a different set of processes, a whole nother set of processes. And then you move into the M2s, the solid state drives, the soldered on the Apple boards and all that kind of stuff. All of that is encrypted. Every bit of that's encrypted. You can't discuss any of those without encryption. And most of those are multiple chips, whereas all the others were just a single chip or two chips at most. These are all multi-chips, and desoldering those and trying to reassemble those is near impossible. And you don't have the pinouts, you don't have the boards, you don't have any. Some people have managed to buy those from Apple to get the Apple ones, but most of the others you don't get. M2s have like 6 different interfaces, so you don't know which one that you need at the moment that you need it. So I'm just describing this process and how bad it is now. As we go through it, you'll see. But financially, I'm a data recovery guy. How do I make my money? I sell the data back to the client. So if I spend, let's say, $10,000 to get to the spot where I can do solid state drives. Again, there's 3 different things that you're going to need, because solid state drives, you need a firmware tool, which the only one exists is a PC3000, and that's a separate one. Like there's a PC3000 flash chip-off tool and a PC3000 firmware SSD tool, and they're different. And another part of the process you have to buy. If I'm doing any of those that's not a drive, if I do an SD card or thumb drive, the most anyone will ever pay me is $200. That's the most anybody's ever gonna, no matter what size. They don't even equate it to size. It doesn't matter if it's 128 gig, if it's a terabyte. They don't care if it's a terabyte thumb drive. If I'm talking to somebody and I say that thumb drive is gonna cost $800, $2,000, they're gonna tell you you're crazy. Somehow they equate the physical size with money. And you can only get about $200. If I spend $10,000 initially to buy all the equipment, then every year it's at least $1,800 in renewals. At least, that's the minimum amount, $1,800. It's impossible for me to do enough work to pay for all the tools at all. You'll never make money. You'll never make a profit. It's impossible. You do all the calculations. You have to have, like, if only 30% of them are ever going to work, and you do all the calculations, by the time you're done, you've got to have like 800 of those in. Every day that you work on them, they take between 2 and 3 days minimum to do. You don't have enough time. It's impossible to do them throughout the year and make money. You need a whole team of people working on them, and you still won't make any money. But that's the problem. And I'll go through those numbers later. But that's where we're at with that. And RAID arrays in solid state is even worse, and it's a terrible idea. So we'll discuss that again when we get to that part. But if you're doing RAID array solid state drives, you shouldn't. That's the best thing I can say. So whatever bug causes a bug in the first thing causes the bug in all of them. And RAID is supposed to survive because of redundancy, because it's going to be a random amount of time before they die. Well, that's not going to happen. They're going to all go at the same time. And when the first one goes, it starts to use the others more and more. So let's do the last one before we...
Well, I'm John. You stole my thunder.
Which part?
Well, I've dabbled in a little bit of everything there. But mainly I've done a PC3000 class as well as flash and solid state. And yeah, you're absolutely right on that.
Okay.
The training was 2 weeks long, and yeah, it was horrible.
So when you got out, how much did you feel like you could actually do?
Probably maybe the thumb drive.
Yeah, right. And that was 3 days by itself.
Yeah.
Right. Yeah.
And
this is the Ace Labs through Teal Tech?
Yeah. Yeah.
Okay.
But
Resolute? Did you do a Resolute class?
no.
Okay.
No. Unfortunately, I wasn't able to do that.
Yep.
But it was a lot of talk and not much action. And whenever we did the action, it was just running through everything real quick. And I'm at my lab, and I'm supposed to take over for a guy that's retiring. And we got DDI, we got PC3000, we got Atola.
Yep.
And it was kind of like deer in the headlights look with PC3000.
Yeah.
Because of all the firmware and everything like that. I've done chip-offs of USB drives. Haven't done any SSDs yet, but that's a nightmare in itself. And I've spent $10,000
Yeah.
on the flash as well as everything and the spider board.
Yep.
That spider board has given me 0% return on investment on that. So
Yeah, I mean, I wondered about attenuation on the spider board as a whole too.
Yeah.
Because what he's talking about is there's it's a square platform with a circle, and it has pins that come out, and the pins can touch each of the locations that you would have soldered to on any solid state device. So if you had a SD card, you put it down, and then there's a pin, and the pin you figure out.
And they're like minute hair-like.
Yeah. And then when you screw it down, it's got a wire that connects to that, basically, that you connect to the correct location. And so there's attenuation between the transfer on the metal and how far down that the metal can go, as opposed to a wire, which is shielded, and there's other things. So I haven't heard...
God forbid you touch the two
Right.
together or
Yep.
something like that. So.
And they're very easy to touch together because they're very close to each other. But, you know, and that's why everybody that I've seen is doing micro soldering, with one exception that Resolute has been building these little snap-on things. So that basically you have a chip, put it down, and then they've already figured out what the board layout is, and then they have a clip, and it clips on, right? Have you got Resolute?
Yeah, I have Resolute.
Right.
That's what I use mostly.
Yeah, right.
Yeah, we have like adapters for each chip, like a T-stop or, you know, something like that, so, or an LVA. So you press down, and it pulls up with these two arms, and you drop the chip in, and it closes down on the chip.
Do you even need a clamshell?
Yeah. So we have like, I have, wow, on my desk I have like a dozen, maybe more.
Right.
So you have to luckily find the right one.
And how do you feel your success rate is when you're done?
Probably about 30, if not less.
Yeah, right.
And then that's because of, as you said before, the different ors and the different algorithms that PC3000 does in their magic.
Right.
And it gets to the point where you spend 3 or 4 days.
Right, and still not successful,
Yeah,
and still
yeah.
don't know what the answer is. Yep. I mean, I feel for you. I know. I mean, I've been doing it. Like I started on some of the first ones back in 2004, 2005, and it's just been a constant spend of money to the point that, and that's why I don't spend a lot of time focused on it. I'm more about, you've got to have a repeatable process in order to be able to produce income. And there's a lot of people who are selling the tools and who are doing things which are, they're making more money doing that than they are ever doing the work. They would never make the money doing the work. They can't make the money doing the work. That's not going to be a solution. So that's kind of why I focus less on that, and right now more on hard drives, and then just on the repair, because let's face it, if I get, let's say 100 thumb drives comes into me, you know what's wrong with 90 of those thumb drives? Somebody left it in the laptop, threw it in their bag, and it snapped off. That's what's wrong with 90 of them, like right there.
Or a suspect.
Like, right. Yeah, they just snap it or do whatever. As long as the chip isn't cracked. Instead of doing chip off, I find it's way better to figure out something you can move it to. So if you can find another one of the same thing and resolder the chip that you need to that thing, that will work more successfully than your 30% on any of the other stuff. And so I've been spending less doing that and more doing the repair like that. Just moving the chip, find something else. But your hard part is when you get to actual true SSD drives, where you're talking about, you know, 4 chips on a board somewhere, then those aren't, it's not a connector most of the time. It may be a resistor, transistor, or capacitor, or something else that's busted and you're hunting those down. But it's not usually the chip, and that's the thing, is from that standpoint.
The right order of the chips.
Right.
And yeah, it's
Yep.
horrible.
Right. So I'm glad we're all on the same page with that, because I've talked with hundreds of people all over the world, and I've tracked all of these things all over the world, and even the people who are doing it, like marketing the crap out of it and saying they can do anything, they're same boat. They're really not more, when they get honest with me and they tell me the real answer of how successful that they are, then that's the real answer, is nobody's getting more than 30% right now of anything. It's just all marketing hoopla. And most of the time completely focused on SD cards. It's not even focused on almost anything else. It's SD cards, because the easier thing is the thumb drive. You don't even need to do it most of the time on the chip off. Most of the time you can just find another one and solder it to it and be done. And again, it's encryption. Most of the other is encryption. So if you get around encryption if you can resolder everything back to another board without making any modifications. You get around encryption. So you've got to get the thing functional again, and you don't have an encryption problem. you only have an encryption problem trying to do chip off where you're separating the two chips and trying to put it back together. So again, repair works for me 90% more than any of the other times I can do anything else. So I've stopped that whole idea of let's disassemble it. I'm focusing on let's look at all the capacitors, look at all the resistors, find something that's broke, see if I can fix that and get that working again. And just sit there with a meter and go over the board and over the board and over the board until you find something that's not working right, instead of taking the chip off. So, but forensics has this big idea that we need it in this exact package, the way it was, the way it is, and we need to interfere in that process by doing chip off, which in the end is not going to work any more than it does with an iPhone. iPhone, you can't do it with an iPhone. Like, that's impossible. It doesn't work. So, have you tried it?
There was one person in England that did it.
Yeah.
But he had the,
I hear those stories, and then when I get to that guy,
yeah,
right?
but he used the same iPhone, or two similar iPhones to do it. And it worked around it, the whole encryption process.
Yeah, most of the time when I actually get, like, because I've seen a couple of these that are like one-offs where they say they can do something, and then I've been able to actually contact that guy, and because I'm pretty well known and because somebody knows, sometimes they'll share something with me about how they do something or do, I mean, you know, this was this whole thing with MFM scopes, if you remember those things back in the day where the CIA, so they could read a hard drive with that, like, when they finally got down to it, what happens is they get like 36 bits of everything that comes off of it. They run it through spell check and do a probability check of what the words were. They didn't get the data off. They got a couple of sectors that had some data on them, and then they did a spell check across it because the error rate was so high they couldn't do anything. And it took them 18 months to do a 36K item. So it's not possible anymore today. It's not possible with current hard drives. Hasn't been possible since 2000, 1999, because of some changes to the way that data is stored, but it's not possible anymore. All right, anyway, so technically this would be a break time, which you saw me ignore that. And so why don't we take a 10-minute break, and then we get into some real stuff, okay? Get some coffee.